Adversarial attacks use subtle perturbations to create deceptive inputs, such as adversarial images, to trick machine learning models into making prediction mistakes. In this paper, we propose Advex, an interactive web-based application that visualizes the properties and impacts of adversarial attacks for novice learners in adversarial machine learning. Suppose Zoe is a learner interested in exploring the FGSM and Zhao attacks on her ResNet 34 models using the CFAR10 dataset. She wants to understand the attack's properties and how their impact varies between models trained with different methods, such as standard and adversarial training. In this video, we will refer to the standard ResNet simply as ResNet and the adversarially trained ResNet as ResNet star. Zoe first loads the FGSM attack with CFAR10 data and her ResNet models. She launches Advex and is greeted by a welcome screen, followed by an overlay tutorial. Upon entering the main interface, Zoe notices two data projectors side by side, each representing the image embeddings of one model. Zoe first observes that the embeddings of ResNet have more distinct clusterings compared to ResNet star. Additionally, she notices from the robustness analyzers that when no attack is conducted, ResNet star has lower accuracy than ResNet. Zoe decides to experiment with the perturbation adjuster, setting the perturbation size to values above 0. In the left projector, the circles start to travel rapidly, while in the right projector, the circles only shift slightly. At a perturbation size of 0.03, the accuracy of ResNet drops to just 57%, whereas ResNet star maintains an accuracy of 81%. From this, Zoe understands that the two models rely on different sets of features for classification. The FGSM attack is drastically changing the way ResNet perceives the dataset, but it struggles to change how ResNet star perceives the same dataset. When the perturbation size reaches 0.03, Zoe notices that instance 6 in ResNet's data projector, an automobile, is incorrectly predicted as a cat. Upon clicking the instance level attack explainer updates. Zoe clicks on an image and enters the comparison mode. Here, she can see the subtle perturbations applied to the adversarial image. From this, Zoe understands why adversarial attacks are known to be human imperceptible, that even though the adversarial image still looks similar to the original, the changes are meaningful enough to ResNet to alter its prediction. Zoe then clicks on the same instance in ResNet star's projector, which is classified correctly. She immediately notices that the noise visualized here has more defined shapes. Since the noise is based on the model's gradient information, Zoe realizes that ResNet star relies on more human-interpretable features for classification, making it more robust. Next, Zoe decides to load the Zhao attack onto her models. As she experiments with the perturbation size, she makes a few interesting observations. Firstly, she observes from the data projectors that, unlike FGSM, which scatters instances across all classes, the Zhao attack generally pushes each instance toward its nearest adversary class, such as dogs to cats and birds to airplanes. Combined with observations from the confidence score view that the Zhao attack slightly adjusts the adversary class's confidence just above the original, Zoe realizes that the Zhao attack pushes instances just past its decision boundary. Because of this, ResNet star, which performs well against FGSM, does not show much robustness to the Zhao attack. Secondly, she notices that as the perturbation size increases, fewer instances begin to move around. Through the step-by-step explanations, Zoe understands that this is because the Zhao attack is an iterative attack, and thus finds the minimum perturbation needed to cause a misclassification. From this, Zoe learns that different strategies result in different attack properties, and a training method effective against one attack may not be so against another. Through her hands-on experience with Advex, Zoe gains a level of understanding that she could not achieve through textbooks or traditional tutorials alone. Zoe continues her investigation, and whenever she needs reminders on Advex's functionalities, she scrolls to the bottom of the interface to see the tutorials included in the general information provider. For more details on our system design and evaluation, please refer to our paper.